Good afternoon, everyone. Hey, thanks for coming. Hope you all had a nice gin o'clock. Right, last talk of the day for track 2. And yeah, I'm Stephen Coe.
My name is Rob Kuijers. I'm an incident response handler with KPN, which is a large telco provider within the Netherlands. And my background is specifically on mobile. So this is what this talk is all about. Well, sort of. So who we are, a little bit of talk through to the presentation. Actually, it's divided into two big parts. I will help you run through the mobile core network and what's all about in there. And Stephen will follow up on the research we did and why we came to it. So, next slide, please.
Yeah, so we'll cover all some background and architecture protocols, how it all hangs together, how it kind of works from that perspective. So the GPRS roaming exchange and how that relates to your data roaming activities when you're roaming on your phone, for example. We'll talk about protocols and then also on what we found, why it's interesting, and then leading on to the actual research we did, vulnerabilities, attack vectors, all that interesting stuff. And we'll obviously follow up with mitigation best practices, as well as some follow-on activities, because we first did the initial presentation a few months back, and we've got some follow-on sort of activities and what we've been doing. Right.
So
okay, we've done that.
Pretty much is on that. Anybody from abroad here? Anybody who's roaming currently? Anybody? That's not money. That's not money. Okay, cool.
Yeah.
Watch this presentation now. So, why this talk? Well, initially in 2013, there was a large telco provider in Belgium was allegedly hacked by the GCHQ, and that kept the interest was from Stephen. So, since I have a mobile background, and Stephen was asking me, so what could be of interest for those intelligence services in this GPRS roaming exchange, so in the GRX. And then we started talking about it and discussing it. And since we are a telco provider, we also have our own GRX connection. So that made us think, well, let's just find out what's running in there, because we don't exactly know. We just put traffic in there and it comes back, but there must be something more to that. So that's how we discussed and started our research. So these are all the things we found online. What could be of interest to the intelligence services? And Snowden then came with his revelations, and eventually it was for us a little bit more clear why the GCHQ wanted to target the GRX. And especially when you look at it, when you are in the middle of the network, you can eavesdrop the traffic. But then again, what can you get out of the GRX? What could be of interest to them? So, please, next slide. Guess what? Mexico doesn't it? So we thought, dude, what the fuck? There's so much going on in there. So let's focus on that part of the network. So I'll first take you to how it actually works, how the GRX is sitting in between, and how a mobile data connection is set up. So what is the interest? Why did it do it? And how you will get, because GRX is a closed network. So how do you get in there? So, and there are questions that Google can answer. So that's why we started our own research. So a little bit of background information, a little bit on mobile core protocols and how it's done. So the concept is, when you have your mobile phone, you have your mobile data settings in there. So of course, your provider, which you connect to, and your mobile data settings. So which APN, so access point name you use, and what kind of MMS proxy, for example, you use. It's all in your mobile phone. But how does that go through the network? First of all, you have your base stations in the network. And I don't know how big the networks in the UK are, but for the Netherlands, for example, KPN has run at about 5,000 sites where they put cells. And each cell is identified by its own unique number. And when you group them together, you have your routing area, which is controlled by either an RNC in 3G or a base station controller for 2G, or in LTE. It's somewhat different because each base station has its own capability to control itself. So when you put that together, you will have a mobile network. And each mobile network across the globe has its own mobile-specific identifier, which is called its mobile country code. For the Netherlands, it's 200. In the UK, it's 234. So each network in the UK is identified by MCC 234. And each operator within those countries has its own mobile network code, which is for KPN 008. I don't know them by heart for the UK, but they all have their own code. And this is how your mobile communicates with the network. So you put in your text, but then again, underneath, it will be translated to these kinds of information. Next. If you compare the size for the Netherlands to the UK, I've looked up the table for the UK. It's more or less the same. It's a little bit longer. But these are all the mobile networks in the Netherlands. And for a small country, it's quite a lot, I can tell you. Yeah, please.
Sorry.
So this is your setup in your mobile phone. So you put in your APN name, your MMS instances, and it's in your mobile phone. You have your IMSI, your SIM card, and this is your unique identifier. With this unique identifier, you make a connection to the network, and then you will be able. You can see here the mobile network code, mobile country code. .GPRS or 3GPP-networks.org. With this specific code, you will make a data connection to the network, and at this point in time, the network exactly knows what to do with it. So when you turn on your phone, you make a connection to the network, and you start browsing. The mobile phone will make a connection to the gateway in the network, and then the gateway strips off any specific mobile identifiers and sends the traffic out to the internet or any packet data network you're connected to. There are some companies who have their own specific APNs for to connect their company networks to people just roaming around in the country. So they can easily maintain stuff or something else, or get to the office network. So the elements used in setting up a connection are, of course, your BTS, your nodes, your home location register, where every subscription is held. It's just like a big database, where every IMSI is registered with any kind of service you are allowed to use. Serving GPRS support node is a node who translate the radio signal to a core signal. And the gateway is just for stripping everything off and getting to the regular IP networks. And then, of course, you have your domain name server. Internally, in the mobile networks, we use domain name servers to route our APNs. So every APN has a specific IP address going along with that. And then you have something in between which glues it all together, which is, of course, the network and your protocols. So getting to the specific parts for mobile, so the 3GPP invented the GTP protocol, which stands for GPRS Tunneling Protocol. And it's a UDP-based protocol, and it only communicates between your SGSN and your GGSN, so your serving GPRS node and your gateway GPRS node. So this is how it all ties together. So you put on your mobile phone, you send some data, the BTS station will make a connection to the serving GPRS support node. The serving GPRS support node will then ask the HLR, well, is this subscriber allowed to use the data service? And if he does, then it's I'm missing the DNS here somewhere. The GGSN will ask the SGSN will ask the DNS, so what kind of gateway should I use? And then the gateway will put on the packet just out on the internet. So this is how it nationally works. Every mobile operator has this kind of network, more or less. So when you look at the GTP stack, so the GTP protocol, it was introduced in 1989, just before we launched GPRS in 1990. And it has several flavors. You have, up until now, with 4G included, you have 3 different types of GTP protocols. This part is maintained by the mobile operator, and the upper level is just your plain IP, what you also would have on the internet. So your user traffic, your WhatsApp messages, your Facebook, your browsing, your mail, whatever. So what I just said, the GTP protocol has 3 versions. The first instance was UDP-based, and it was on port 3386. Version 1 introduced 2 new ports, so you will have your control plane, so which is telling the network what to do with your traffic, and it resides on port 2123, and all your user data is in 2152. So all your mail, internet, whatever, is all on 2152. For the 4G network, they only decided that they needed a new control plane, so they upgraded GTP to GTP version 2, and it resides also on the same port. If there are any questions in between, just ask, by the way. So this is the header for the GTP protocol. In the header, you have your specific type of protocol. It can either be GTP or GTP prime. And GTP prime is mostly used for billing services. So internally, because we are a mobile operator, we want to earn some money. And if you're putting data through the network, we want to get something out of that. So there's GTP prime used for. There's a version field in the header. Could be either 1 or 2. In this case, because it's GTP version 1, it's 1. Then you have the set of messages. And that can be, well, a whole bunch of messages. The most common are create, delete, and update. So when you put on your phone, you make a connection, it will create a PDP contact, send it to the GGSN, and you will get a connection to the internet if you're allowed. The most used in this case, so what we see at this point in time, because not that many operators are having a live 4G network currently, the most GTP versions we see running across the network is GTP version 1. And since the network needs to know which GTSN to get its traffic to, in each tunnel or each header, there's also your GTP tunnel endpoint. So from your mobile phone throughout the network, you have your own specific user tunnel getting to the GTSN, and then you're out in the open. And this is how it looks like when you put Wireshark, because Wireshark is well aware of GTP. So you will see the same identifiers here. The type of protocol you use, the version which goes along with that, the port which it runs on, and also the specific message type. In this case, it's just a transport PDU, so the connection is already set up, and it's the user data which is pushed through the network. And there goes your tunnel endpoint identifier just below there. Yes, there you go. So Wireshark is quite aware of how GTP works. That makes it interesting. These are all the information elements which are in the GTP create PDP context message. So what could be of interest for an intelligence service to look at? Well, could be the APN, so the access point name, if you would want to know something about a specific company which used GPRS. Of course, your IMSI, because that ties into you or to your mobile phone. The end user address could be of interest. Could be. User location information. Hey. So GTP is aware of your user location. I have to say, user location isn't a mandatory field in the GTP. In GTP, it's a optional field. But I see many providers use end user locations. And your EMI. Your EMI is like your MAC address for your mobile phone. So it's a specific, unique number for your mobile phone. With that unique number, you can identify which... Yeah, go ahead.
I'm just curious what resolution the user location is at. Are we talking like a cell? Or
yeah, you're talking about a cell. Yep. So your EMI is your specific, unique hardware address for your mobile phone. So how does the GTP set up a connection? So, yep, the SGSN will ask the DNS, I have this APN, can you please give me an IP address to route my traffic to? The DNS responds back to the SGSN with the correct gateway address. The SGSN then does a create PDP context message to the GGSN. GGSN checks the user. It also checks your, for example, quality of service. It's a slightly different quality of service than we are used to in the internet. It gives you the bandwidth you're used to allow or used to get from your subscription. So how much bandwidth you're allowed to use. And it will pass it on to the GGSN. So, okay, that's fine. Come on with the traffic. And then you start browsing and start WhatsApping, Facebooking, whatever, and it's all passed through to the network. And also the response, of course, otherwise your screen will keep blank. And as soon as you're finished, it will send delete PDP context back to the GSN, which will tear down the connection. This is, in essence, how a mobile data connection works in a mobile network, or the core part at least. So, and then you start flying and getting abroad, and you will bring your phone, you're going on holidays. So where does the GPRS Roaming exchange ties in then? So you'll see here two mobile networks, one in the UK, and BT has mobile network code 76, I see. And yeah, let's make a connection to the Netherlands. So I'm here, I'm roaming, and I want to tell the wife via WhatsApp how great it is here. Yep. So the SGSN from BT will interrogate the HLR at KPN, saying, well, I have this guy over at London and he wants to make a connection. Is he allowed to? And yes, I am. So then I said, I put up my WhatsApp message, get to the SGSN. SGSN said, okay, this is just an internet connection. This is the gateway address. I know, but then it hits the end of the BT network. And it should go through, and then I get out. But there is a network in between which ties up all the mobile network operators across the globe. And that network which carries the traffic is the GRX. So it's a global network, and every mobile operator who allows roaming mobile data roaming has a connection to the GRX. There's not one GRX provider, there are several, and they all have their own specific GRX network. And mostly what they do is just, they're quite big tier 1 carriers, and they just grab a part of the existing network for that. GRX has evolved, and eventually the GSMA decided that it should carry more than just only data traffic. So now they have a new setup, which is called IPX, and it's the IP exchange network for mobile operators. And you can carry their, for example, LTE signaling, voice traffic, eventually, because 4G doesn't have a dedicated voice service, it's all packet switched. And for every part every service which a mobile operator uses, you have a different part in the IPX network. Any questions on this quick run through to mobile core networks? Was I that clear? Wow. With my okay. Well, this is a list of the biggest GRX providers. And as you can see, we also are a GRX provider with our company iBasis. And this is more or less the location where they reside. But like iBasis, they have around the globe 4 POPs: Singapore, Hong Kong, the States, and in Europe. So.
All right.
So Stephen will now get you through our research, how we took it on.
Okay, thanks, Rob, for that. Right, so you now have some background on GRX, what it's about, and how it hangs together. So now we're going to look at some GTP traffic. So going back to the main reason why GCHQ allegedly hacked Belgacom was to actually do a man-in-the-middle of the routers on the GRX to get some information. So from here, we're going to have a look at what's in it, what sort of interesting information is in it, and then from there on, how we get to it. So Wireshark, so this sort of traffic is captured on the GRX router itself. Okay, so if you have a look at it, you've got, hang on, sorry, I need to be.
Okay.
Thanks. You've got the endpoints here. So these are the IP addresses of the GGSNs. So where the tunnels are built, right? And then the user endpoints are these. So the 10 address is probably the handset of your mobile phone, and the 66 dot whatever is, in fact, the destination. So in this case, the user payload is actually like a DNS query. So it's doing a DNS request. So the 66.28 is the DNS server in this case. So that's how it looks. Now, right. So I've got this traffic. So I then dumped it on some sort of network forensics software like Network Miner in this case. I can use others. And you can see that all the frames load, but you can't really see a lot of user plane traffic. There's, So there's no Yeah, you don't see much at all, in fact. It's all no packets that it can recognize. So what do we need to do? So because the traffic is within a GTP tunnel, you have to really strip the GTP headers to see it. So I spoke to a guy on the team. His name is Wesley. He wears a black shirt with a different message every day, like no kidding. And this, anyone recognize what's on his shirt? Yeah, that's right. It's brain fuck. Yeah, so that's cool. So he wears all these different black shirts every day. Anyway, so he basically wrote GTP strip, which we'll share out distribute. It basically goes through the PCAP file, identifies the different elements of the traffic, and checks for different headers, and to make sure that it is the traffic, then it strips it and rewrites it. So it just basically strips the header. So pretty cool. And then now, if I load the same traffic back onto Network Miner, I now see all sorts of information. I get host details of the traffic. I get session information, of course, where you've been. So it's just there, right? It's just all the clear text stuff, where you've been. Obviously, your images, where you've been browsing, what you've been doing, where you're going to. And of course, if you use clear text protocols like FTP, HTTP, that's all in the clear. So this is, so user traffic information. So whether you're on Facebook or WhatsApp or browsing some site, that's all basic network traffic. That's there. So that's interesting. The other thing that's interesting is location details. So as Rob mentioned, within the GTP headers, there's the location details, and I'll go through them now. So you've got the IMSI, which is there, so that identifies you, your device anyway. You've got all the country codes and the mobile network country codes, and also the location area codes. So that pretty much identifies where you are. So within, of course, the range of the cell towers. And then, of course, you've got the IMEI, which is, as Rob said, the unique sort of MAC address for your device. So that is different, obviously, if you're an iOS phone or a Samsung phone, all that sort of stuff. And, so if I go, so with the MCC, MNC, and the location area code, I found this website that you can basically plug the information in, and that translates to coordinates of location. So just zooming in, it gives you GPS coordinates of exactly where you are within that range. So now with this traffic, once you're in there and you've captured it, you can see what you're doing and where you are, and of course what device you have. So yeah, whether you're on a Samsung, your iOS phone, for example, then it becomes very interesting from a specific payload attack perspective. So I know where you are, I know what sort of phone you're running, and then I'm going to try, if I'm going to own you, then I'm going to try some payload that's appropriate. So that was interesting. Okay, so that's why this information is interesting. And we know what it is, we know who the GRX providers are. So the next bit of our sort of thinking was, okay, how easy would it be to get to access this network? So in theory, this is a closed network. This is operators only accessible. But in any case, we'll do some sort of landscape sort of overview of it. So see what's out there. For the purpose of this research, what we did was essentially did the reconnaissance part of this whole kill chain. So it was pretty much banner grabbing and also some limited port scanning to identify systems. Okay, so how we started was we basically went into the GRX core and dumped the routing table. Okay, so it's fairly big. Well, it's the 4.8K subnets all up with about 320,000 address space overall. Okay, so that's how big that looks like. And then using mass scan, anyone use it much? Yeah? Yeah, it's cool. It's async and it's pretty fast. I selected a few ports and started just, hey, see what's open and what's out there. So we found that there's about 42,000 live hosts, a combination of open ports and ping requests, ICMP. So out of 4.8K, yeah, it's about 42K. That doesn't make sense. Oh yeah, out of 320,000, sorry, yeah, it was 42K, yeah, sorry, I was looking at the wrong thing. Right, let's look at this. So GTP traffic is between GGSN. So if you look at to identify GGSNs, so GTP endpoints, we crafted the basic echo and reply, basic GTP request echo to send to the GGSNs. If you have a look at it, essentially that's the request, the message type request, and the response is that. So I've got the payload, and yeah, you send that off, and of course you get the reply to look. That's how we look for the GTP endpoints, and yeah, to make it fast, I use ZMap because anyone also use ZMap?
Not
Cool.
many.
It's it's very fast. It's async, and it has this ability to generate Ethernet frames directly, and it sort of bypasses your IP stack, so it's really fast. It'll go gigabit sort of wire speed. Yeah. So, but using these parameters, it'll accept the probe arguments for UDP, and then away it goes. So, using this technique, we found a whole bunch of GGSNs and GTP ports, and just to confirm that it is talking, as in, if you remember back what Rob showed you on the GPRS or the GTP sort of tunnel setup, once you've identified the endpoint, you send a PDP context request, and so we used a protocol OpenGGSN, and within that there's a SGSN emulator, which allows you to then query and test GGSNs. So it's pretty handy. Yeah, look it up if you're interested. That's the sort of command, the default command you would send it. There's a lot of default sort of parameters you send it. And in the first phase, if it's a valid GGSN, it'll respond with a right response. So from there, at that point, you know it's ready to talk. And if you have the right parameters, whether you brute force it or have a legitimate parameters, then you can then establish the GTP tunnel. So that's pretty much as far as we got to verify the GGSNs. So that's one thing. The other element of the GRX that's important is the DNS server, because when you're about to create a connection, it will create DNS, look up what the IP address is, and then go from there. So DNS is important. So I'll just quickly go through that. The query looks like that. So the globally agreed APN is internet dot with your MNC for your network and your MPC for your country code. And then the response, if it's a GRX DNS server, will look something like that, and the IP address are all the addresses of your GGSNs endpoints. Okay, so that's, yeah, so similar to your normal DNS, I suppose, but just a little different. Okay, so now we start thinking, okay, so we expect these systems to be there. How vulnerable are these? Now, are they up to date? Are they running old versions? So we started doing this bit of threat profiling from that perspective. So purely based on banners. From a DNS perspective, normal sort of dig command to get versions. We found a whole bunch of DNS running these versions. And yeah, they're fairly old. This bind version has got DOS vulnerabilities. This bind version, it's DOS and some overflow. So yeah, not great, but gives you an idea of some vulnerabilities there. So that's the DNS servers. Now, so we thought, what else may be there? Because in theory, in an ideal GRX network, that's pretty much it, right? GGZs and DNS, that's all we really need to establish GTP tunnels for roaming. But we started looking for normal common services. We found a whole lot of mail servers.
So this makes you wonder, what does an SMTP server doing in a transit network? That's no good.
Yeah. So
Where only a mobile specific equipment should be in, actually.
okay. So in terms of vulnerabilities, that's got root exploit, that's got code execution, that's also got code execution, that's got overflow, and some are really old, right? So some of these, the SendMail 893 is really old. So that's no good. So we looked at we also found some FTP servers running around, and you think, wow, well, that shouldn't be there, and it certainly shouldn't be
On GRX now.
yeah, and it shouldn't be so old. So there's remote code exec there, overflow.
Is this on the APN or is this on the server that the APN service is listing?
No, this is, so it's on the GRX network.
Okay.
So
Inside.
inside.
Okay, so more DOS for that old FTP server version. Overflow is there. Yeah, and that. So it's pretty old. Again, some dating back to 2001. So that's kind of worrying. Of course, we didn't verify this with exploits. Web servers.
At least we're not telling you.
A lot of Apaches, some Microsoft IS, old. Again, a lot of code exec for that, for Red Hat, based, Apache, code exec, obviously for IS 5, 6. Old, yeah,
Very
Oracle
old.
HTTP version server. Yeah, so it shouldn't, yeah, that becomes fundamentally disturbing because these shouldn't be here at all, right? We also saw a lot of telnet daemons, and you can see this Alcatel stuff. There's obviously Cisco, Huawei,
Huawei Quickway. Yeah, that's a
Linux.
nice one. You know them.
There's Windows 2K, Windows XP, nice. All Solaris, yeah. So it's starting to look like, yeah, really mixed up. Then, of course, there's a lot of SMB stuff as well, right? So I just thought I'd look. So if for
And
those,
that should definitely not be there.
yeah. So for those who may not know, so there's null sessions. You can enumerate information without anonymously, without real credentials for shares. Various versions of Samba and Windows, and some are quite vulnerable, and more vulnerabilities there. Okay, so yeah, it's really mixed up. Just an example of null session enumeration. So if you have a sort of fairly badly configured SMB server, you can get password policies, and that's from a real machine out there. And of course shares information. Then from there on you can start brute forcing and getting potential unauthorized access. Right, so the other thing we thought was SMP is interesting because that's around and can reveal a lot of information. So with the private string, you can do a lot, right? You can start things, you can shut things down, you can get all sorts of information. So this sort of stuff we found, and just to make it easier, there's all sorts of iOSs, routers, probably switches as well, 3500s, 2900s, VPN gateways, Ericsson IPOS as well. So and that's using the private string. So presumably I could write to it. With public string into it, oops, I've got, yeah, Windows, Huawei routers, more Huawei stuff, OS 5.0, that's kind of Solaris 8, isn't it? Yeah, so Sun Netris. So really badly misconfigured systems out there, right? And Tandberg, that's interesting because that's kind of like a conference phone. So, yeah. And some Sizewell modems.
Yeah,
Okay. So this, as a summary, these are the things that we quickly found during this light survey. These are the number of instances of different services that's out there. And really, the worst thing is, this is, oops, all across the internet. And
so, presumably GRX should be a closed network, shouldn't have any connection to the outside world.
And we verified this host from within the GRX as well, so we had to go through this permission to the data center, get all the checks, limited access, and then we find the same host is listening on the same service. So really, they're really mixing it up. So they're advertising routes. Sorry, yeah?
What's on the web service? Did you share information what you found on the web service?
Yeah? You web service?
Yeah. Or DT, what did you find? Did you look at what's on the contents?
No, just banner base.
Right.
Yeah. All right. So, internet. Yeah. So that's actually really bad. And so out of the 42,000 live hosts, there's about 5,500 hosts from over 200 operators reachable for the internet. So, and then that's across all the different kinds of services that's exposed. And well over 15 operators had GTP ports exposed. So these are live GGSNs accessible from the internet.
And we did a responsible disclosure directly after we saw it. So we all mailed them with our findings from this research. And from this, I think it was over around about 30 operators who were exposed on the internet. And how many operators do you think responded? No, that's not true. Some are very responsive, but no, it's not zero. Close, 4. So from these 4 operators, or at least from the 30 mails we sent, only 4 responded with thanks for the information, we're going to hunt it down and shut it down.
Yeah, so it doesn't bode well for the telco community. I think there's a lack of awareness, maybe certainly in how you configure things, how you divide your networks, how you harden things, how you patch things. So yeah, it's a bit scary. So the message really is that, yeah, you don't even have to be in GRX. You can just hack something, pivot through, and then you're in GRX potentially. So I've got a quick conclusion, and then we've got some follow-up stuff as well. So, okay, so GRX traffic is definitely interesting. There's a lot of data and location information that, yeah, that's really valuable for everyone. GRX is really not that close due to mainly misconfiguration, I imagine. It's a lot of operators exposed. Yeah, a lot of hosts. Yeah, mainly misconfigurations and all the old stuff that we used to see in IT infrastructure many years ago. And yeah, the lack of filtering and just best practices just lacking from that perspective. Yeah, need more testing, more awareness, more coming to these conferences, I think. Okay, some best practices, you would all know this, just, patch, update, harden. And for BGP specific, you really need to, not advertise your GRX routes to the internet. So they can't get to it from the internet. Yeah, use BGP authentication, accept routes only from your providers that you have roaming agreements with, because then their users can roam with you and really restrict it. In terms of ingress filtering, yeah, so the two, you really only need GTP in, you need DNS in, and you need ICMP for troubleshooting. That is it. Block everything else. And the other thing is, which we're looking at as well, is the application-specific firewalls. That's GTP, SCTP, diameter aware, so that you can do payload inspection, validation, all that sort of good stuff. Okay, follow-up actions. So since the original talk, as Rob said, we spoke to quite a few of the operators exposed. We're still working with some to help them understand why you need to filter things off, why you need to harden things. And then we also did a rescan to see, what's changed the last 3 months. The pluses mean that there are actually more ports exposed. And so there's more GTP ports exposed. There's more telco ports installed. So clearly people are installing more GGSNs and mobile
Building
stuff.
up their 4G networks.
Yeah. But the minuses mean there are less. So there's actually nearly 60%, nearly over 50% less instances across the protocol. So maybe the last talk had some effect. We don't know. In terms of GTP exposure, I sort of plotted the operators that are concerned. They're mostly Africa, Asia, there's a couple in Central America. Oops. Yeah, there's only one in Germany that I saw, and then the one in the middle is kind of Kazakhstan. But yeah, so Western Europe's pretty good. But yeah, that's kind of distribution of misconfigurations for GTPs, for GTP ports. Right, what else have we been doing? We're testing our GGSNs, we're doing fuzzing, we're doing exploit development to help the vendors do their own research. So we'll have follow-up activities on that. There's just not a lot of research and testing done for GGSNs and those sort of mobile sort of telco equipment. So we're doing that. Watch your space. We're talking to a few vendors who have telco-specific firewalls. So we're talking to Checkpoint and Fortinet, who say they have all these application filtering, they'll do validation. So we're testing that to make sure the claim is right. So yeah, and if it's good, we'll work with them. So definitely. We're writing some auxiliary modules. So we'll release that soon. We're getting that checked. So you can look for GTP port yourself. And we'll put some payload in so it'll be easier to find and test. So we'll watch out for that as well. And
so the GRX is actually a part which is provided by the GSMA. GSMA stands for GSM Association. So all mobile providers group together in this association to make the networks better and to be more secure and to provide more services for their customers. We've looked into the RS-77 as it was when we did the tests. So actually it states, "Thou shalt take care of." It's from 2007, you see. Seriously? Thou shalt take care of integrity, confidentiality, and availability. That's actually in 3 words what this document was all about. It doesn't give you any specific directions, any specific requirements. So as a mobile operator, I think you get lost. So we had this conversation also with the GSMA. So, well, guys, we did some testing and we found this. What do you think of it? Well, they were very eager to listen to our presentation. So that we did. And If it's a coincidence, I don't know, but there's going to be a revised version of the RS-77, so new and improved. And actually, when you look in the document, they really made an effort to make it more understandable for mobile operators who don't know very much of IP. So they really made an effort to get real good work instructions in there. So the pros are also the old RS-77 wasn't binding. So you can fuck around as a mobile operator and they won't hunt you down and let you fix your shit. So what they do now is they have a large section in the RS-77 which is binding. So they will come up with binding security requirements that every provider has to comply to. And they also included best practices, eventually. So that's good. The cons is it's still not as detailed as you would like it to be. So people who don't understand IP directly, or in that sense, the bits and bytes, they still can make mistakes. And there are no testing guidelines, which could be, can come in handy if you want to test your network yourself. And there's no monitoring or enforcing. So I have to tell the GSMA, well, this is an operator who doesn't do his work correctly, as you stated in your RS-77. So I don't think many operators will do that. We are now in discussion for the second bullet. So we'll put in our own testing, what we did ourselves, to put in there. So people are, other mobile operators are also capable of doing their own tests. So, yeah, we are slowly getting there, but we're not there yet. So, yeah.
Yeah, so questions? Yeah, that's us, thank you. And any questions?
So were you able to identify what types of devices you were interacting with over the network, over the internet? Like when you scanned and you saw these open ports, were you ever able to say, this is a nano BTS, this is an IP access device for extension, this is blah, blah, blah?
For your understanding, BTSs are not on the GRX. So only mobile core equipment. So your SDSN, your GGSN, and your DNSs should be in there.
Well, the reason why I'm saying that is because it makes sense the reason why you're seeing office equipment. Because people
No. There is an agreement between the GSMA and mobile operators. We didn't tell you that, but there is an agreement with mobile operators and the GSMA that you identify a specific piece of IP space for GRX purposes that you have to write down in your roaming agreement. So you have to tell the GSMA and your other roaming partners, this is a specific IP range I use for GRX. Nothing else should be in there. So.
Right, I'm just saying, I totally understand where you're going with that, and I think this is great research. I just think that it might be interesting to identify whether or not you're seeing office-based equipment for the extension of GSM and GPRS, because that would actually explain why you're seeing SMB and things like that when you're actually attaching to the network. Because these range extenders will essentially look like GSM equipment and be on GRX, but then they'll bridge the actual office network with the GSM. And if you're seeing it through the internet, then that explains the intersection.
There should be no radio equipment connected to GRX. So that's the range extenders you won't find there.
Okay.
Any
Anyone
more
else?
questions? No more questions?
Okay. Yeah, thank you very much for your attention.